Today, another practical example of what daily life in the workshop looks like. The customer arrives with a problem regarding the engine coolant temperature, so naturally, we have to start troubleshooting. This also means we need to narrow down the fault. That is it the control unit? Is it the sensor? Or do we perhaps have a broken wire? For this case, we have a sensor simulation device, and with it, we can narrow down the fault, and we will show you how that works now.
We have now exposed the vehicle to this point. That means I've already removed our hose here, which we need to take off so we can reach the sensor. Down here, we also disconnected and exposed the plug so that we can measure it to check. Is the wiring broken or is our sensor broken? Next, we need our sensor simulator. It is very easy to connect. We just go here, connect to plus and minus on the battery. Alternatively, you could use a separate battery or find another way to get 12 volts. Now, we obviously need the right cables and connectors. I have selected the appropriate cables from our test kit. This means we have the direct connectors here, and these are the connection cables for now. There are also more included in the set itself. Here we simply go to ground and here to positive. Now we go ahead and connect the cables directly here. Now we obviously need to know where to connect in the plug. I looked that up beforehand. This means we have a pinout diagram for the plug here. In this case, it is a 3-pin plug, of course. We have our ground on the 3rd pin and our signal on the 1st. So one black cable for ground into pin 3. And in pin 1, as I said, we have our signal cable. So now we have prepared everything so far that we can go ahead and check it via the resistor and later see in the speedometer or on the tester whether we have a signal from the cable to our onboard diagnostics, that is to the control unit. Here we now confirm in the simulator first, go over here to our temperature sensor. We confirm that again as well. In this case, we have an NTC sensor. It is now showing 20,000 ohms of resistance. We are now turning that down. I will tell you why in a moment. That means we are now going all the way down to a low value. So the lowest value we can set, which is also shown above, would be 100. This means we can simply see from our technical data that we would have 48 kilo ohms. That is minus 40 degrees, but we naturally want to know where we usually are in the range. At 80 degrees, that means we need 0.32 kilo ohms here. Accordingly, we will now go ahead and, since the speedometer or the display shows ohms here, we will set this to 350 ohms, and now Jens will show me what the temperature gauge on the speedometer does, or what we see on the tester.
We have now pulled up the live data on our diagnostic tool. I will monitor these here just like on the instrument cluster to easily see if the values change plausibly when PT changes the resistance at the front. PT, could you change it, please?
Yes, set it again here. Go back down. That means you should have a relatively high value now.
Yes, 127.
Exactly. Now I will go to about 350. That puts us in the range where we actually need to be.
Yes, and we can definitely see that something has changed in the instrument cluster, just as it has here in our live data. That simply means we have narrowed down the fault. It is definitely not the cable or the connection, so we have to take a look, replace the sensor, and then we will check again. We have narrowed down our fault using the simulation device. It was definitely not the cable, it was the sensor. We have replaced it. We no longer have any errors in our diagnostic device here. That means the repair was successful.
You can see how great the device works. It can even do much more. And everything else you need to know about this device can be found in the description text in our online catalog, or of course in our pushing catalog.
Yes, and one thing is very important. Subscribe to our channel so you do not miss any more videos.